The pioneering electric car company Tesla has suffered a series of very public challenges since the beginning of this year. Its high-profile CEO, Elon Musk, calls this period a production hell. Most of the troubles revolve around the company's Model 3 sedan. It's the first mid-price electric car. Earlier this week, Musk took us on a tour of his Silicon Valley factory. And this is the first time network cameras were allowed inside the Model 3 production line. Going to look at the batteries.
We divided the general assembly into 3 parts, and the middle part is where we put the battery pack and motor in. And so we call that marriage.
Elon, what's the hardest part? Pre-marriage, marriage, post-marriage?
Right now, marriage is the hardest part.
Marriage is the hardest part. Elon Musk's relationship with outside analysts and investors is also going through a rough patch these days.
I'm definitely under stress, so if I seem like I'm not under stress, then I'm going to be clear, I'm definitely under stress.
In the past month, Tesla has issued a voluntary recall of 123,000 of its older Model S vehicles, dealt with a fatal crash of a vehicle equipped with its semi-autonomous driving system, and suffered a downgrade of its credit status on Wall Street. The Model 3, still in your mind, is the face and the future of the company, is it not?
Yes, absolutely.
But the most important thing on his mind these days is solving production delays for the Tesla's new Model 3 sedan here at his massive factory in Silicon Valley. You started saying we'll do 5,000 a week, then, okay, that didn't work out, we'll do 2,500 a week, and now it's a little over 2,000 a week. Does that trouble you?
Yeah, no, that's true. I need to figure out how to be better, and then we can be better at meeting goals.
Tesla's future is tied to this car. When Musk introduced it last summer, the Model 3 was billed as the company's first mid-priced, mass-produced electric car, accessible to middle-class customers, not just the super wealthy. You said to your team, everybody get ready to meet the demand. We're going to be in production hell.
Yes.
But you didn't expect this kind of production hell, or did you?
No, it's worse than I thought.
Why is that? Why is it harder? What happened?
We got complacent about some of the things that we felt were our core technology. We put too much new technology into the Model 3 all at once. That this should have been staged.
High tech goes in the cars, but it also builds them. This is widely regarded as one of the most robotics-driven auto assembly lines on the planet. Elon, part of the thing I heard about the Model 3 is that there's too many robots, that maybe...
Yeah, I agree.
You think so too? That maybe you need more people in here working?
We do.
In some cases, the robots actually slowed the production, right?
Yes, they did. We had this crazy complex network of conveyor belts, and it was not working. So we got rid of that whole thing.
This is cool, Elon.
Yeah.
Realizing it needed an overhaul, Musk personally took over the Model 3 production line at the beginning of April.
We're aiming for really extreme levels of precision, more than any other vehicle in the world.
He says he has resorted to pulling all-nighters at the plant.
When things get really intense, I don't have time to go home and shower and change, so I just sleep here.
I want to see. Where is that?
Yeah, so
I want to see.
I mean, it's pretty boring overall, really.
It's actually cold in here, too.
Yeah, I like it cold.
So you like it cold?
I sleep on the couch over there.
So you're just laying here on the couch?
Yeah. Last time I was here, I actually slept literally on the floor because the couch was too narrow.
Yeah, I was going to say. And Elon, I have to say, it's not even a comfortable couch either.
No, it's terrible. This is not a good couch.
What does the number say for the last 7 days? What is the number?
2,071.
You pleased with that?
Yeah.
For the time being?
Yeah.
Musk feels like all the overtime is paying off. And now he says the Model 3 line is back on track.
And we're able to unlock some of the critical things that were holding us back from reaching 2,000 cars a week. But since then, we've continued to do 2,000 cars a week.
Do you think that this is sustainable? This pace is sustainable?
Yeah. So we'll probably have, I don't know, a 3- or 4-fold increase in Model 3 output in the second quarter.
But Musk critics have heard predictions like those before. A future the automaker has yet to reach. But Elon, you may be one of the few people to see it, because a lot of people looking at you don't see it.
The problem people have, a lot of the analysts, is they kind of look in the rearview mirror instead of looking at the front windscreen.
What do you mean by that?
This has very frequently been why people have underestimated Tesla, because they would look at Tesla's what Tesla's done in the past and use that as proxy for what we're able to do in the future.
On April Fool's Day, Musk mixed his optimism with dark humor, On social media, in the midst of widespread concerns Tesla might collapse, he tweeted this: "We are sad to report that Tesla has gone completely and totally bankrupt. So bankrupt, you can't believe it." You know people are nervous and they're worried. You are aware of that. So knowing that, why would you do an April Fool's joke that you did?
Oh, because there were all these media articles saying that Tesla's going bankrupt.
Yes.
So I thought, well, I'll just do an April Fool's joke that we did go bankrupt.
But Elon, that's not funny when people are nervous.
I mean, it's April Fool's. People should, lighten up, okay? It should be pretty obvious, I think, that I'm not going to joke about bankruptcy if I think it's remotely real. I'm feeling pretty optimistic about where Tesla is at this point. At this point, I can have a clear understanding of the path out of hell. And I do not, until recently, have a clear understanding. Elon Musk says anyone who pre-ordered the Model 3 when it was unveiled last July should be getting their car in about 3 to 6 months. And that's about 6 to 9 months later than they were promised. So listen, I have to say he really is on the case. When you hear about him sleeping at the factory, you go, yeah, sure, right. But I asked employees when he wasn't around, he actually does sleep in that room. And I said, but why are you doing this? It's not like you're out there, painting a car or running a machine. He said, because I can solve the problems in real time. I look at that board, I can see where a problem is and go and make the correction and go check it out myself. So he's very serious.
What I like hearing about him is he's showing us him making his mistakes in real time and trying to fix them, tweaking. We never get to look inside the clockworks. While, what he's learning about automation matters for him. Who knows if it'll help with the car, but it's a crucial thing happening to all businesses, learning that sometimes you can over-automate, and to watch that happening in real time is
also fascinating to let us in when he knows he's under the gun, when he knows that people are complaining. He says, sure, come on in. He's very calm, very confident, and he's very matter of fact. He's very matter of fact in the way he speaks, but I just think he's terrific and on the case.
Bold and creative.
Yes, he thinks outside the box, Nora. We like that.
Yeah, absolutely.
We'll have more of him at
8 o'clock.
That's right.
Yes.
So, just talking about the future. I think that the most important point I want to make is that what I referred to earlier, that we've realized that the true problem, the true difficulty, and where the greatest potential is building the machine that makes the machine. In other words, building the factory. And really thinking of the factory like a product. Not sort of a hodgepodge of things that are bought, where the machines are kind of bought from a catalog. But actually, just like we do with the car, we don't try to create a car by ordering a bunch of things off a catalog. We design the car the way it should be, and then we make, either we or with working with suppliers, make all of those individual components. And there's almost nothing in a Model S that's in any other car. And I think the same approach is the right approach to take when building the machine maker, the factory. I actually think that the potential for improvement in the machine that makes the machine is a factor of 10 greater than the potential on the car side. I think maybe more than a factor of 10. And I've really come to appreciate that, over the last 2-3 months in particular, when I've sort of just been on the production floor all the time and sort of seeing things, running production personally at a detailed level. I don't even have a desk or an office anymore. I just basically, I'm just basically standing on the production floor and occasionally meeting in a conference room. And it's like, wow. I do my favorite thing, which is apply physics first principles. It's like the best tool possible. And it's like, wow, when you think of a production facility on a fundamental level, for a given size of factory, the output is going to be volume times density times velocity. So then let's sort of look at our factory and say, okay, what is the density of useful to non-useful volume? It's crazy low. It's like 2 or 3%. If you look at volumetrically, not just on a planar level, but volumetrically, it's literally 2 or 3%. When you say car to non-car ratio, volumetric ratio, like, wow, okay, that seems like there's a lot of room for improvement. And then you say like velocity. What is a reasonable expectation for the exit velocity of vehicles from the factory? And at first you may think that, say, some of these advanced car factories around the world are very good at making cars, and they may make a car every 25 seconds. And that sounds fast, but actually, if you say, well, the length of the car plus some buffer space is approximately 5 meters, and so it's taking 25 seconds to move 5 meters. Okay, that's 0.2 meters per second. Basically, you're not much faster than a tortoise at that point. And so it's like, wow, that really doesn't seem fast. Like, how come these factories, like a sort of slow walk would be approximately, or slow to medium walk would be 1 meter per second. And a fast walk would be 1.5 meters per second. And the best car factories in the world are doing 0.2. Like, seems like you should be able to have cars exit at least walking speed. This doesn't seem so crazy. And then the density improvement, like there may be as much as an order of magnitude improvement in density possible as well, going from maybe 2 or 3% to 20 or 30% of the volumetric density being optimal. And like you can also think of it like the design of a modern system on a chip or a computer. And you say, if you look at, say, the complexity of the board, and you see how close together the line traces are, and how focused things are on clock speed and data transfer from RAM to, say, a solid-state disk or the internal CPU cache. It's like, wow, there's crazy potential for improvement here. I think at least an order of magnitude potential for improvement on production. And so with less, like significantly less engineering effort, we can make dramatic improvements to the machine that makes the machine. I think I think like probably a lot of people will not believe us about this, but I'm absolutely confident that this can be accomplished.
Yeah, there are opportunities we're finding all over the place, and as you start to shift some of the design resources that have been improving motor technology and power electronics or batteries, and are working so hard to try and find 0.1% of efficiency gain or performance gain on those different systems. And when they start to go and look at the factory, they say, oh my gosh, this is crazy. We can find, as you were saying, easily 10s of percent or 20, in some cases hundreds of percent efficiency gain that were sort of unheard of in terms of what you could do in the design world. So the impact there is pretty phenomenal and quite close at hand.
Yeah, so we're basically going to design a factory like you design an advanced computer. And in fact, I think use engineers that are used to doing that and have them work on this. And I found that once you sort of explain this to a first-rate engineer, the light bulb goes on. They're like, wow. As JV was saying, they spend huge amounts of effort trying to get a fraction of a percent of improvement on the product itself. But actually, that same amount of effort will yield an order of magnitude greater result if you focus on building the machine that builds the machine. And it's just that a lot of engineers don't realize that this is possible. They think that there's like a wall. They're basically operating according to these invisible walls. So we just need to, we're in the
process of just going through and explaining those walls don't exist. And I think it's going to be pretty amazing.